This is question 11, part B of the Seoul National University's Mathematics Aptitude exam that was held in 11th of February of 2020. The reason I chose this question is because this is a great example of what a typical limits question of a calculus learning student will have to encounter outside of the syllabus of IBAHL. So let us go through. For some fx, which is a cubic function, the limit as x approaches 1 of sine of x cubed minus 2x squared plus x all over e to the fx, e to the cubic function, minus e equals 3 over e. In this case, find f of minus 1 plus f of 3. So here's how we would do it. This requires manipulation and the first example of practice of trigonometric limits. So let us start. So the limit as x approaches 1 of sine of x cubed minus 2x squared plus x all over e to the f of x minus e equals 3 over e. And because this limit exists, we have to check if the denominator and numerator is a 0 over 0 or an infinity over infinity situation, as they must be indeterminate form. Because if the limit of the denominator tends to 0 and the numerator infinity, that would be infinity over 0 form, which is infinity. 0 over infinity, on the other hand, will be 0. So if you input 1 for sine x as limit as x approaches to 1 of sine of x cubed minus 2x squared plus x, only the numerator, we see that this approaches 0. Because as x approaches to 1, that would be sine of 1 minus 2 plus 1, sine of 0, and we know that sine of 0 is 0. Therefore, we can deduce that because the numerator is 0, and the limit still exists, the denominator must also be 0. Therefore, the limit of x approaches 1 of e to the fx minus e must also be 0. And by this, we get e to the f of 1 minus e equals 0. Therefore, we deduce that f of 1 equals 1. Therefore, with this information, because, it doesn't have to be this, but because we're also given that fx is a cubic function, therefore being a polynomial, we can divide it into the both numerator and denominator to make it a 0 over 0 indeterminate form, and the limits will not change. What I'm saying is we can rewrite this as the limit as x approaches to 1 of sine of x cubed minus 2x squared plus x over, the original was e to the f of x minus e, right? What we can do is we can divide the numerator and the denominator by f of x minus 1, because we know that f of 1 is 1. Therefore, the denominator of the numerator, so f of x minus 1, will tend to 0. Therefore, the top part will become a 0 divided by 0 indeterminate form, and we must do the same thing with the denominator. So the bigger denominator and the numerator all is a indeterminate form of 0 over 0, all divided by 0 over 0. Therefore, the limit must still exist to 3 over e. Therefore, by our rules for limits, we know that the limit of the big numerator must equal to 3, and the limit as x approaches to 1 of the big denominator must equal to e. It doesn't really matter which one we use, but because we have a polynomial inside a trigonometric function in the numerator, I think using that will be more helpful. So from that, if we only look at the big numerator, we can deduce that the limit as x approaches to 1 of sine of x cubed minus 2x squared plus x all over some cubic function f of x minus 1 equals, not e, but 3. The limit of a numerator equals the numerator, the limit of a denominator equals the denominator. And here we can do the same thing because, and what I'm going to do now is use the fundamental identity of a trigonometric limit of the most prominent one if you are a physics student as well. The limit as x approaches to 0 of sine x over x equals 1. And this is a really, really important trigonometric limit identity, so you must remember this. The proof of this is by using geometry for plus minus theta, the area of the small triangle, area of an arc, and area of a big triangle, and so on. Anyways, I'm going to make this limit into that form because we know a identity for a trigonometric limit. So I'm going to rewrite this as limit as x approaches to 1 of sine of x cubed minus 2x squared plus x all over. So the original is f of x minus 1. And I'm going to divide both the numerator and the denominator by what's inside the sine function, x cubed minus 2x squared plus x, and x cubed minus 2x squared plus x. Because the manipulation is done both by the numerator and the denominator, this big limit, this whole limit will also equal 3. But notice on the numerator side, this is just another form of the identity, and I'll show you why. The limit as x approaches to 1 of sine of x cubed minus 2x squared plus x divided by x cubed minus 2x squared plus x. I will let over here, let t equals the function x cubed minus 2x squared plus x. Then as x approaches 0, t would, as x approaches 1, which is our limit over here, as x approaches 1, then, sorry for my bad handwriting, as x approaches to 1, then t approaches 0, because 1 minus 2 plus 1, that's going to be 0. So we can rewrite the whole thing as the limit of as t approaches 0 of sine t over t. But we've seen that this is an identity, so this must equal to 1. Therefore, we can rewrite this as the 1 over the limit as x approaches to 1 of f of x minus 1 over x cubed minus 2x squared plus x equals 3. Right? Because the numerator is 1 and the denominator is in the limit. Therefore, this limit over here, the limit as x approaches to 1 of f of x minus 1 over x cubed minus 2x squared plus x equals 1/3, right? Okay, if you ended up here, you're 90% done. I'll factorize the function below. That would be limit as x approaches 1, f of x minus 1 of x of, that's x cubed, x squared minus 2x plus 1, so that is x minus 1 squared equals 1 over 3. At this point, we must notice that for this to exist, fx must be a cubic function. Because if it weren't a cubic function, then this would not have existed, right? So seeing that this limit exists to 1/3, we can positively say that that f of x minus 1 equals x times x minus 1 squared over 3. Because that is just saying that the limit here exists. But if we ignore the limit, then that function must always be true for all x values, right? Because as x approaches 2, that will become another value. As x approaches 3, that will be another value. So the 1 is really irrelevant in our scenario. So we can finally deduce that fx equals x times x minus 1 squared over 3 plus 1. And here we are, and the question asks for f of minus 1 plus f of 3. Therefore, f of minus 1 is, so this is minus 1 times minus 2 squared over 3 plus 1 plus f of 3, which is 3 times 2 squared over 3 plus 1, right? So this is minus 4 over 3, the 3 cancels out, plus 5 plus 6, right? Which is minus 4 over 3, which is 18 over 3 plus 18 over 3 equals to 14 over 3. Therefore, f of minus 1 plus f of minus 1 plus f of 3 is equal to 14 over 3 in where this limit exists. Thank you very much.